Hello and welcome. In this tutorial, we are going to improve on our previous factorization program by doing the following. We're going to add a variable which is going to count the factors. So previously, we just printed them out. We're just going to add something that's going to count them. And we're going to do it because the count can be very significant. If there's only two factors, then that means the number is a prime number. So in other words, our program is also going to test if the number is prime as well as give away the factors. So how do we go about that? Well, we first need to create some kind of a counter, and that counter needs to be an integer. Since types are dynamic in Python, we can just have a counter equals to 0. And by default, it's going to operate as if this is an integer. Now, where are we going to increment or increase the value of this counter? Well, obviously, when a factor is discovered, which is in this operation right here, if the number we entered, 15 in this case, is divided by another number with no remainder, like 3, then we print 3 as a factor. We can also increase the counter. Counter equals the counter plus 1. Now this is called incrementing. And if I can just illustrate it a little bit, it is the new value. So this operation stores a new value into counter, which is 1 bigger than whatever that previous value was. So let's test this out, and now we're going to print the counter. So it should run the same way as the last one, but it'll print 4 at the very end. Yes. So right at the end of this program, we can do another if statement, and we can say, hey, if counter double equals to 2, that is the only possibility, there are no others. If the counter double equals to 2, we can print the number is prime. So since that is num, we can go string num is a prime number. And we can remove this printing of the counter. So let's try this out. Invalid syntax. We're meant to be adding that, so that's concatenating. So let's try that again. Enter a number, 17. 1 is a factor, 17 is a factor. 17 is a prime number. So that's pretty much the entirety of the upgrade we needed to turn our program not only to list factors, but also identify prime numbers. I don't know, we can try it one more time. Maybe 51. I reckon 51 is not a fact. Oh, it is 3 times 17. Do I know any prime numbers 50 and up? Maybe 53. Yes, 53 is a prime number. So that is all we're going to do in this tutorial. In the next one, we're going to handle lists and look at how those work. And the one after that will be back in prime numbers, trying to generate a list of them. This is an interesting activity on which there's a lot of algorithms. And believe it or not, even the value of Bitcoin is tied to the scarcity of prime numbers. That's all for today. See you in the next tutorial.